All right, so we're going to find cosine of 15 degrees, the exact answer, all right, using one of our sum and difference identities. All right, so dealing with cosine here, what I want to do is I want to express this 15 degrees in terms of two angles that I know how to find cosine and sine of. So in this case, that's going to be 60 and 45, or I could use 45 and 30, either one. All right. I'm going to rewrite this as the cosine of, I'll go with 45 and 30. 45 minus 30. That'll give me 15 degrees. And now that it's written like that, I can use my cosine difference formula. All right. So it's going to start with cosine A, so cosine of 45, times the cosine of B, so cosine of 30. All right, and then notice keep in mind what your sine is. This is a plus, and then it's going to switch to sine of those same two angles, sine of 45 and sine of 30. All right, and then all we have left to do is just evaluate each of these four little expressions. So we're going to get root 2 over 2 for cosine of 45. Cosine of 30, I believe that one's root 3 over 2. And we get a plus sign. And we'll get root 2 over 2 for the sine of 45. And then for the sine of 30, that's going to be 1/2 times 1/2. Nice. Simplify, we can multiply these straight across. That'll give us a root 6 over 4 for that first one. And then we'll get a root 2 over 4 plus root 2 over 4 for that one. The last thing you can do here is actually combine into one term, one expression, one denominator. There we go. Root 6 plus root 2 all over 4. That's the exact answer for cosine of 15. And that's all these sum and difference identities are going to do. They're going to allow us to kind of find sine and cosine for angles, I guess, that are increments of 15 degrees. All right, but it's always going to, I guess the backbone is always going to be that 45-degree angle. We have to kind of leverage that each time. All right, we'll do one more here. Sine of 285. So I got a couple of options. I could say, I could do, what is it? I could do 300 minus 45. Oh, what am I thinking here? I could do 330 minus 45. All right, I know how to find sine and cosine of those angles. Or I could do, what's 285 minus 45? 240. I'm going to do 240 plus 45. That way I can use my sine addition formula. All right, you can use either one, but I'm going to write it in terms of addition. All right, so this is equal to, got my paper wet. All right, sine of 285. This is equal to the sine of 240 plus 45. Okay, and so I'm going to be able to use my sine addition formula here. So it's going to be sine of the first one times cosine of the second one. So this is equal to sine of 240 plus, sine of 240 times cosine of the second angle. All right, and it is a plus sign in the middle. And that's going to be plus cosine of my first angle, so 240, and sine of my second angle, sine of 45 degrees. All right, I got the formula in there. All right, now I need to know the sine of 240 degrees. I did this once before already. Sine of 240, that's going to be negative root 3 over 2. It's the y value at that point. So this one's negative root 3 over 2 times cosine of 45, that's root 2 over 2, plus cosine of 240, that's going to be negative 1/2. So negative 1/2 times root 2 over 2. I guess I can go ahead and get rid of my plus sign here in the middle, huh? We'll just call this a minus instead. There we go. This is going to give me a negative root 6 over 4. Negative root 6 over 4 minus, this will give me a root 2 over 4. And then make it into one term. It'll give me negative root 6 minus root 2. All of that is over 4. All right. And then if you want to actually check your answer, go ahead and type in the sine of 285. See what that gives you. And then come down here and do the exact same thing. All right. Let's see. We're going to compare that expression to the answer we got. Negative root 6 minus root 2. All of that over 4. And yes, indeed, it does give us the exact same answer. Cool. Yay, we did it.